is called the Heisenberg's uncertainty principle. The Heisenberg uncertainty principle states that the position and momentum of a particle cannot be determined at the same time. Okay? The position and momentum of a particle, Heisenberg uncertainty principle. It says that the position and displacement, position/displacement of a particle cannot be determined simultaneously at the same time. You either determine the position only or the displacement only at a fixed time. Okay? Don't forget that. Don't do what? Don't forget that. That's what it's all about. What is a conductor? What is a semiconductor? What is an insulator? A conductor contains what? Free electron. Conductor conducts heat and what? Electricity. Because of what? Free electron. Because it has what? Free electron. Example is like metals, like iron, copper, aluminium, and so on and so forth. Then we now have something called semiconductor, or let's do insulator, because semiconductor is going to be our last. Insulator. Okay? Insulator is a substance that does not conduct neither heat nor electricity. Doesn't conduct heat or electricity. Why? Because absence of what? Of free electrons. All right. Then we now have the one called semiconductor. Semiconductor is intermediate. It's in between conductor and insulator. It's here. Why? Because it possesses some of the properties of conductor and it possesses some of the properties of insulator. Okay. So it means that at a particular condition, semiconductor can act as a conductor. At a particular condition, it can act as an insulator. So just know that. Okay. For example, semiconductor include, insulator include wood, paper, plastic, and so on and so forth. Then insulator, they include, let's put intermediate, all right? Intermediate. That's between conductor and insulator. Okay, they include silicon, and what? Germanium. All right? They are known as what? Metalloid in chemistry. They are used as what? Semiconductors. All right? So let's look at semiconductor. In semiconductors, we have two types of semiconductors. Two types of semiconductors. We have two types of semiconductors. What are the two types of semiconductors? We have the intrinsic and the extrinsic semiconductors. Intrinsic and extrinsic semiconductors. Right? Let's look at that. Intrinsic and extrinsic semiconductors. All right? So semiconductors. We have what? Intrinsic and extrinsic. Intrinsic and extrinsic. Okay? So, intrinsic are usually known as pure conductors. They are pure in nature. They are pure semiconductors. All right? They include silicon, you understand? Those are intrinsic semiconductors. Why are they pure? They are carriers. Their carriers are generated by thermal expansion or thermal excitation. All right? So when you heat them, they become what? A semiconductor. When they are at room temperature, they are insulators. So they are excited or they are made semiconductor by what? Increase in what? Temperature. All right. Then for the extrinsic, this one are the artificial, okay, formed from what? Formed from addition of what? Impurity. Of impurity. All right. So when you add impurity to a substance, it becomes an extrinsic semiconductor. All right. They are also referred to as doped semiconductor. Okay. All right. So we have two types of extrinsic semiconductors. We have the N-type and the P-type. Okay. We have the N-type and the P-type. Under the N-type, what do we know about the N-type? The N-type has extra electrons. Okay. Then this one is usually called the donor impurity. They donate. All right, they donate. But usually, what we are naming here now, what we are explaining here now, are the types of impurity. Okay, types of impurity. Okay, so this one is the donor impurity. We have N-type and P-type impurity. Then this one is the recipient impurity, the P-type impurity, and this one has a hole. It has hole to receive it. Okay, extra hole. All right, it has extra hole to receive from the donor. So this one is usually the what? The acceptor. Impurity, or you can call it recipient impurity. Recipient impurity. So that's that for semiconductors. There is something about there's something called holes and carriers. Okay, holes and carriers. Do we need this one? Let's just leave that one. Let's look at diode versus transistor, what they are used for. All right, diode versus transistor, what they are used for. You don't want to be doing what we don't need. Okay, diode and transistor. Diode, transistor. What is a diode used for? Used for rectification. What is rectification? Conversion of what? DC to what? AC. Conversion of direct current to what? Alternating current. That is the function. All right. It usually contains P and N, PN junction. Okay. It is one way of P to N junction. You know that the diode is made of impurity, right? It's made of impurity. It's like it's a semiconductor. So it's used for rectification. So here is transistor. All right. This one has 3 terminal. It has 3 terminal. It's a device with 3 terminal. It's used for what? For amplification. All right. Of signal. Used for amplification of signal. Used for amplification of signal. This one, like you use it in radio tuning and all of that. Signals and switching. Okay. And also switching. All right. So you can find this in an alternator. Okay. You are going to see diode in an alternator. All right. You will likely see diode in an alternator, because an alternator, most of the time, alternator in cars, most of the time converts direct current from the battery to alternating currents. All right. Alternating current converts direct. Wait, what does the alternator convert? Sorry, wait. Oh, no. Convert alternating current to direct current to abeg diode. Thank God I brought this example. Convert direct current to alternating current for diode. All right. For example, in the car battery, okay, the alternator induces the EMF. All right, induces EMF. Okay. Then alternating current is formed by the alternator. AC is formed by the alternator. Then the diode we have inside does what? It converts this AC to what? DC. That's what charges the battery. All right, that charges the car battery, because that's the function of the alternator in cars. Okay, so do not forget DC to AC. AC to DC. I just put down the same thing again. The same thing that I cleaned. I put it down. AC to DC. Always use this car example to remember. All right. The EMF is induced from mechanical energy from the car's engine on the alternator, and the alternator produces what? Alternating current, because it's an alternator. Then when the alternating current is formed, the diode inside the alternator converts this current to what? To DC, direct current, that is going to charge the battery of the car. Because if you use alternating current to charge the battery, it's going to damage the cell. Don't forget that. Diode is used to convert alternating current to direct current. There is something called fiber optic. All right. Fiber optic transmits light through thin glass / plastic. It works under the principle of total internal reflection. TIR. Okay, fiber optic. All right. What is it used for? In medicine and nursing, it is used to view internal organs. All right, to see inside the body. You can use it to see inside my throat, inside my tummy, my intestine, and all of that. You can just put it and you'll be seeing it on the screen. All right, so that's what it's used for. It's used for diagnosis. Also, it's used for LAN, which is called large area network. Okay, it is also used laser beam. All right. There's laser. Laser is amplification, when you use transistor to amplify signal. The signal from stimulated radiation. You use transistor to amplify the signal of stimulated radiation. You get something called laser. All right. And what is laser used for? Usually it's used for cutting in medicine. Okay. For cutting. That's what laser is used for. You also use it for communication and research. Also used for medical treatments too, like skin treatments. All right. You can also use it for communication. That's use it for network. All right. It's also used for research. I think that's all. Thank you all for taking this class from the start to the end, and I wish you good luck in your exam preparation. I pray that God answers your prayer. This laser that you are seeing here, this laser also has dangers, all right, such as eye damage. Can damage the eye. You know, it's a product of radiation, all right, amplified radiation. It can give skin burn. Also, it can cause fire hazard. It can cause fire. It can generate toxic pollutants. Because this laser can be made with solid, it can be made with liquid, it can be made with gases. So depending on the make. So I wish you good luck in your pursuit for admission and in your exam. God is definitely going to answer our prayers. See you in the next subject.